Okay, so I've got this apparatus set up for electrolysis. There's some copper sulfate solution in the bottom. It's got that really intense blue colour to it, which is characteristic of solutions that have got Cu2+ ions and copper 2+ ions. So I'm expecting that when I turn the power on, I'm going to collect copper on the cathode, and because it's copper sulfate, I'm expecting to see bubbles of oxygen at the anode. Okay, so I'm just going to show you, because I'm hoping it will look quite good, that these are the carbon electrodes, the carbon rods to start with. I've started off with completely clean ones. I've got them set up to go into the solution, and I'm going to turn the power on now. Okay, now you can see that there's some bubbles building up on this anode here. Okay, a few little bubbles. And when I lift it out in a minute, we should be able to see that copper has deposited on the cathode. Okay, so a nice little lot of bubbles coming off that anode. Let's lift it out. And you can see there's already some copper depositing all over the cathode. Now, what I wanted to show you was, or what I wanted you to think about first really, was if the copper ions are coming out of the solution and depositing all over that cathode, what will happen to the concentration of copper in my solution? If I leave it going for a long period of time, that copper sulfate solution, the concentration of it, should change. And what I want to show you is an experiment that I've had going at the side here that's been left for quite some time. So you can see the difference in the colour of the two solutions. Now these started off exactly the same, but this one's been going for quite some time now. It's been going for about half an hour. So you can see that the concentration of the copper sulfate has changed, it's decreased. There's far less copper ions in that solution, that's why it's got a less intense blue colour to it, than there is in this solution here. And if I lift out my two electrodes, hopefully you can see there's a much thicker deposit of copper, a much more intense copper colour all over that cathode. Okay? I want to have a think about what's going on at the anode in a little bit more detail. So this is my anode, and we could have electrodes made of metals just as easily as we have them made of carbon, graphite. So I want to imagine what would happen if we had a metal electrode. Now we know metals are made of metal ions in a nice giant lattice, and there's a sea of delocalized electrons around them, so I've represented that by those red dots. Now we also know the anode is positively charged, and we know that it's positively charged because the electrons are being withdrawn from it all the time in order to go around the system and be squirted out at the other end where the cathode is. So while the electrons are being drawn away from this anode, that means there's not very much holding these positive ions in their lattice anymore. They were attracted to the sea of electrons, but of course that's being drawn away. So we end up with ions falling off our electrode into the solution. Now if we think about what's been happening in terms of our copper sulfate solution when we were electrolyzing it, copper ions were coming out of the solution and sticking themselves onto the cathode. So this would be a genius way of replacing those copper ions that are being removed from the solution. And if we have a look at the apparatus I've got here, this is the experiment that I was doing before, but as you can see now I've got a piece of copper as the anode and I've still got my carbon rod as the cathode. So what should happen over time is that my anode, my piece of copper, will gradually dissolve into the solution in order that the concentration of copper ions stays the same in the solution. So we wouldn't see, even if I left it going for half an hour, we wouldn't see the colour of that solution change very much, but we will still be able to see copper depositing on the cathode. So ions are going to migrate from that piece of copper into the solution and then from the solution onto the cathode. Okay, so we're just going to put them in there and confirm that we still do get copper on the cathode, and we probably won't be able to see that getting any smaller because it will take quite some time to do it. If I lift this out already, you can see that there's plenty of copper deposited all over that cathode. Okay, So it has genuinely worked. Now the reason I'm showing you this experiment is because this is the process behind electroplating. So if any of you have got jewellery that's gold plated or silver plated, they will have used this principle to do it. They sometimes call it dipping, but really what they're doing is electroplating it. So I don't have to use a carbon rod here. I could connect anything I like to this and get the copper to deposit on that. So I'm going to try now with one of my spatulas out of the lab and see if I can get that to get a copper coating on it. Let's see how we go. And there we are. I've made a copper plated spatula. And I can try it with all sorts of things. As long as the item is metal and will conduct electricity, it will work. So that's got a tiny bit of copper plating building up on it. I'm going to try it now with my house key. Here we are, which looks fairly grimy and slightly brassy as well. But we're going to try dipping that one in and see if we can get that to copper plate as well. So there we are. In we go. Lift it out, and my key has started to copper plate as well. Now, this is a brilliant technique, this is a brilliant strategy for people who are doing electroplating to use, because you can imagine that they might have dozens and dozens of items, so cutlery or napkin rings or jewellery or whatever it is that they're electroplating, and over a period of time, if they weren't replacing the ions in the solution, then they would gradually run out. So it's really important that we have a piece of metal as the anode that's the same as the metal ion that's in the solution, that is the same as the metal that you're intending to plate with. So if I were wanting to silver plate, I would perhaps use something like a silver nitrate solution and a piece of silver. And that way, the silver ions would migrate from my piece of silver into the solution onto my item. And if I was a manufacturer doing this, I would know when I needed to upgrade my experiment, because my silver anode would have virtually dissolved away and I'd have to replace it with a fresh piece of silver. And that would be an awful lot easier for me as a manufacturer than trying to drain tanks of a whole load of solution and fill them up again with fresh solution. So it works out as a really practical, really convenient way of managing electroplating on a large scale.